hours later, or even next day. Is it possible? No. So we need to make this possible. So what is the donation after circulatory death? We are not taking any heart in United States or in India. We are not taking any heart who had this donation after circulatory death criteria. That means their heart is not beating. So how it happens? When the family would like to withdraw a life support, patient has a non-recoverable illness or injury and has suffered neurological devastation but has not been deemed brain death. He is not brain dead, but they need to
which through the help of different chemokines and cytokines then infiltrate into the tumor microenvironment. Depending on the cell types and the resident immune cells present in the tumor microenvironment, if the cytotoxic T lymphocytes can initiate clearing of tumor cells via inducing cell death by different mechanisms like apoptosis, autophagy, and necrosis. The presence of immune-evasive cells like MSDCs, cancer-associated fibroblasts, and tumor-associated macrophages can inhibit the T-cell mediated cytotoxic
identified additional 5,217 DCD donors. So DCD, we are throwing out this heart, but if we can keep this heart alive, that heart can be acceptable. So who is doing right now? The United Kingdom, Royal Fraport Hospitals, London, Cambridge. So they use this DCD heart because their government allowed them to conduct this study, conduct this transplantation, because they showed that doesn't matter if it is DBD or DCD, they have the comparable result, and they already did more than 50 DCD heart transplantations. So that is, how do they do that? Because this is the data. So that's and the last year I went to Cambridge, the Royal Fraport Hospital in England, and then I met with all the collaborators. I visit their lab. I do their surgery, how to do that. So they use some special instrument called the Transmedics, or heart in a box instrumentation. So I have been there for them. I got training, and these are the leaders: Dr. Lodge, Dr. White, Dr. Mixer. They are the leaders in the field of DCD heart transplantations. They are the pioneers. So I got the training from them and then came back to the United States. And this is the concept. This is the heart in a box. This is the machine, the Transmedics. This machine is approved over there for heart. We have this machine in the United States, but not for the heart. Or we have this for the lung. The lung is approved, but not for the heart, because heart is the simple pumping organ, beating organ. So this is the machine that can keep a dead heart alive. So once the circulatory death occurs, we can get this heart, put it in the machine, and it can keep continuously make the heartbeat open. The heart can beat for a longer time. 6 hours? Yes, 6 hours. We can keep this heart 6 hours in this machine without altering the normal physiological or biochemical parameters of the heart tissues, without making any damage to the heart tissues. So this is the OCS device, makes it possible to recondition the heart. It mitigates damage. It recondition heart, assess the OCS lung, as I told you, that already been used, but now it's a time for us to consider for OCS heart in US. So we got a $4 million grant in 2020 to conduct the DCD heart research at our institution, Baylor College of Medicine, over the next 5 years. So this is the machine. We had this machine. This is a highly expensive machine. So we got it. We brought it from Transmedics to conduct our basic science research to see, to keep the heart, how long it can keep it here. So and what are the damage to the cardiac parameters, the cardiac tissues, cardiomyocytes over the time period, and how we can target a particular signal, and how we can make this heart more viable in support of this machine. So this kind of basic science research, along with the physiological research, we are going to do. We already started, so you can see here I'm doing this this kind of study. So this is interesting, and hopefully we'll come up with some nice idea. So the future of heart transplantations that can be a paradigm shift concept. So we do have the TransMedics OCS, we do have the OCS console where you can put the heart. We needed the donor heart, that is DCD heart that had been that had not been used before is thrown. Now we can use this heart in this box in a machine. We have a dedicated surgeons to procure the heart. We do have all these instrumentations and support to take this heart out and then keep it in put it in the TransMedics OCS and transport to anywhere where we go, whatever we can, whenever we can. So this is a small video. You can see the how we do the work. So it's a highly skilled surgeons here. So once a donor heart is available, it can be transported through ice so you can transport it if it is far. You can the helicopter or so. This is the cooler. The heart has on ice. So this is the concept right now. So it has to be done within a certain time period. Now we will change the risk that I already said. The risk, if the time is more than 4 or 5 hours, that heart is not viable in ice. That's why we have to say tata bye-bye of ice. Now it's the time for the organ care system, the heart in a box. So this machine can save a life. This machine can keep the heart alive for a long time, beating. So we use the blood from the patient and make the heart to be pumping on this device for a longer time. That the company says that you can maintain 6 hours to 8 hours, but our objective, our research, we want to improve this and make it 12 hours to 24 hours by adding some cocktail solutions, by adding the nutrients during the artificial circulations in this machine. So we need to provide all the nutrients, reagents, cellular transfer molecules, all the inhibitors, all the inducers, all the antioxidant supplement, because that can produce the ROS. So this basic science, molecular biology part, what are the cocktail solution we are going to use to make this heart viable for longer and longer time. As you can see in the Hawaii, there are a lot of hearts are available, but it cannot, it is a total waste because we need to provide all the nutrients, reagents, cellular transfer molecules, all the inhibitors. With our new technology, our invention, we can increase the time and it can be usable for the different areas of country beyond the 6 hour limit. So this is the future. So we are going to do a lot of research and we are going to implement and we are going to try to approve this in the United States so that we can also use the DCD heart. The ability to safely transplant a donor heart from DCD donor could be a paradigm shift to potentially increase the pool of viable donor heart to help more patients suffering from the end-stage heart failure. Thank you. I hope you like the presentations. And if you have any questions, I'm happy to answer.
Thank you so much, sir. This was really very much enriching talk. Like it was very energetic and you finished well in time. And I think our students are much more benefited with your lecture, and you might have seeded much more research interest on our PG students mainly. Thank you so much, sir. We are really privileged to have you today. Now the topic is open for interaction. So I request Mrs. Bonani Bindani to kindly conduct the question and answer session.
Thank you.
Yes. So this is the questions everybody asking, because we are going through the COVID-19 pandemic. And as you know, the Houston now becoming the hotspot, and we are experiencing a lot of patients, COVID-19 patients every day admitted to our hospital. And the curve is not flattening, the curve is increasing. So we need to fight with that. Yes, obviously, there are patients. So COVID-19's they can affect who is immunocompromised or something, because some patients, they are endemic, and as you know, susceptible to the Houston COVID infections. So our doctors have their own strategy. So each hospital have their own strategy how to manage the patient, because you know, if your immunity is strong, you can combat or you can fight with the COVID. But if you are immunocompromised, because if you have a heart transplant, you are giving immunosuppressive drugs, right? So you are more susceptible. So you have to be careful, and doctors they need to manage how to take care of this kind of situations. So definitely, so they are more susceptible. That I cannot say properly, but that every patient is different, and every patient have their own pre-existing conditions. Every patient's way of lifestyles is different. Every patient's, because in India, people are taking too much painkiller medication, so many things. So we cannot generalize this. If you have something pre-existing, that will definitely reflect through your disease severity and the prognosis, and the treatment can be modified accordingly. What did you say? It's truncated. The last line, I couldn't hear you. What do you say? Oh, in the event of future heart failure, or what? Oh, as I told you that the heart failure is the elderly disease in most cases. But there are cases, the people with young age, they also got the heart failure. But if you have some genetic predispositions, so that can make a patient more vulnerable or more prone to develop heart failure in future, obviously there should be a thing. But if you are in a proper checkup and your doctor and take the advice for your doctors and what you should do, what you should eat, and how to control the other conditions, you will be fine. So you need to do the checkup of your heart, the ECG, every 6 months or every 1 year to check how the heart functioning. Is there any blockage in anything? How? So you have to you need to control your cholesterol. So you need to. So if a person, if their heart is weak, still the patient can live with certain limitations, with certain restrictions. So that's the different thing. But anything can happen to anybody. That still, that's why we are doing research. The cause, what is the cause, ultimate cause? Some patient, the cause of cancer, the lung cancer. Sometimes we cannot, I cannot make a rigid comment on that, but anything can happen and anything cannot happen. Suppose in case my grandfather, my great grandfather, he used to smoke a lot. And then he lived a long life. But I know a person who is 22 years old, he never smoked in his life, he got a lung cancer. And everybody knows that the cigarette smoke is the cause of cancer, lung cancer. So that depends on how your body fight, how the body make you to live, and how your food habit, how your the social habit, and how you maintain, how you keep you healthy. That's the mental. that I believe. If you think I have a disease, I'm going to die, you are going to die. If you think I have a disease, I'm going to fight, you will fight, and you do not have any other complications. That's something that's psychological, I think so. And if you think the other, if you need the proper something like that, they should follow their doctors, what they are saying, and make proper precautions. What did you say? Why? COVID-19 damage anything. COVID-19 nowadays, COVID-19 attacking your digestive systems. So it's not a lung. COVID-19, initially when we heard about the COVID-19 January, February, it goes to the lung, it attacks the S2 receptors, and then it enters the lung, and the lung damage they occur. But they are changing. Even there are reports that they can attack the digestive system. So they can they also attack the heart. So that details, I'm not a COVID-19 specialist. So frankly speaking, I don't know the actual answer for this. So currently in India, we do preserve heart on ice. Not only India, US also. So once we get the heart, we administer the cardiopulmonary solutions and then put the heart on ice and then take it to the transplant center. But if you need to make this heart, first you need to choose the heart. So if you choose whatever we are choosing currently, the brain death heart, that procedure is same. But if you want to shift, if you want to do the paradigm shift, if you want to increase the heart transplant pool, and then you need to move to the DCD heart. That is not using, nobody is using right now. So this DCD heart, you can put it in the in this kind of machine. But the TransMedics, this kind of, the problem is India with most of the people, they can't afford it. Because the one TransMedics organ care system, it's very, very, very costly, very costly. So I don't know how, but India has brilliant minds, so they will come up with something like that. Because that's why I'm talking about the Dr. Devi Sethi. He is providing world-class surgical treatment facility with very less cost. So the government need to take care of it. Government need to implant a more insurance policy for poor people or middle or low-income people, so they can affordable health insurance and with big coverage. And if we can make this kind of our own TransMedics, our own heart-lung machine, or our own heart in a box in India, because India has brilliant mind, they can make it. So if we can make any kind of device that can mimic the current TransMedics, like this organ care system, and if we keep doing research by having the animal heart into that machine with the blood circulations artificially, we need to do a lot of research to do that. So we can come up with something cheap that. So that is the long way to go, because here also we have to run a long way to make it implemented that the DCD heart can be used in US also. For India, in near future, hopefully we'll see something better. No problem.
Thank you. But not the least, we have come to the of two enlightening lectures of today's webinar. So, may I now request and respectable faculty of our department, Dr. Ifshit Chakravarti, Associate Professor, Department of Zoology, to kindly deliver vote of thanks.
Am I audible?
Yes, sir.
Thanks, Luksa. This is the last part we have to complete. Our most valued invited speakers, respected Principal Dr. Somnath Mukhopadhyay, convener of IQAC, Dr. Amitabh Rai, from various institutions, and all my colleagues. It's a great honor and privilege to propose the vote of thanks on behalf of the organizing committee of the Department of Zoology of Dinabandhu Andrews College. We are extremely thankful to Dr. Nupur Mukherjee of ICMR at Mumbai and Dr. Nandan Kumar Mondal of Baylor College of Medicine in Houston, Texas, USA, for accepting our request to act as resource persons in the webinar. I, on behalf of the college, further extend a very heartfelt gratitude to all speakers for gracing their important as well as valuable research works and sharing with us your findings and opinions today. I take this opportunity to extend our sincere thanks to our principal for his guidance and support. I must appreciate to provide this Google Meet platform which enables us to make this event possible. I, on behalf of our department, thank Mrs. Banani Bindani for arranging today's webinar right from the scratch. We thank you all for being with us this evening. Really, it's been a great pleasure. Thank you very much. Good night. Stay home, stay safe.